Here we go. AP Calc, we got week 5, problems 9 and 10. Looking at problem 9 first. The graph of the function f is consisting of 3 line segments. Okay, this right here, when we get this, that you are defining a function as an integral, and this is the graph of f. I need you to put down that g prime of x is equal to f of x. And some of you did that. Great job. Okay, you proved it in part B, but I need you to put this here because then this can carry through the entire problem, that you can always have this linkage set up, okay? So when it says to compute g of 4 is the integral from 1 to 4 of f of t dt. So that means that from 1 to 4, I am looking for the area. So you are getting this area here. And then we are subtracting that area there. And if you do that, then you end up getting 5 halves. Okay, so double check that. If you're asking for, they're asking for g of -2, which is the integral from 1 to -2 of f of t dt. Okay, then we know that that's the opposite of -2 to 1. So -2 to 1, that's the area that you are doing right here. Okay, but once you do that, that's the negative area of that triangle right there, okay? So you can go and calculate that, okay? When we look at part B, find the instantaneous rate of change of G, okay? And with respect to x, at x equals 1, here's why this linkage. So G prime of x is equal to f of x. So we know that g prime of 1 is equal to f of 1, and f of 1 equals 4. Done. It's worth 1 point. Okay. Then when we get to find the absolute minimum of g on the closed interval. Okay, remember this absolute minimum value of g? Anytime we had absolute, we had to have a table of values. And how do we know, whoops, not f, but g. And how do we know what values go on here? Well, first of all, we have to know where the endpoints are. So we'll put in -2 and we will put 4. The other place we have to check is where the function g prime of x is going to be equal to 0. Well, how do I know when g prime of x is going to be equal to 0? Well, that's going to be the same as when f of x equals 0. Well, where does f of x equal 0 from -2 to 4? Well, it would be at 3. That's where it equals 0. So understanding when does that derivative equal 0, that's the other critical point, is where the derivative is equal to 0. So it shouldn't change, your setup should not change because of the fact that you've got a function defined as an integral. The same rules apply. Absolute minimum value, you need a table, okay? On that table go my endpoints and my critical points, all right? Now from here, I have to go get g of -2, g of -2, and I need g of 4. Oh, wait, isn't that what they just told me to get in A? Yes, yes it is. So I have that this is -6, this is 5 halves. So I better go and figure out, is 3, so I need g of 3. So if I do g of 3, that's the integral from 1 to 3 of f of t dt, okay? And from 1 to 3, that's just this area right in here. And that's kind of like a mess at that point, but Okay, so I've got 2 trapezoids, it looks like. Okay, and I can get that area. And I believe that that is equal to 3. So once you get that table of values set up, now you are qualified to talk about what is the absolute minimum value. You can't talk about that by talking to me about the derivative increasing, then decreasing, or decreasing, then increasing. So it has to be the absolute minimum. No, you need a table of values. And now we can talk about your final correction should be the absolute minimum value is -6 when x equals -2, okay? And last but not least, for this one, second derivative of g is not defined at x equals 1 and x equals 2. How many of these values are x coordinates of points of inflection of the graph of g? Justify your answer. Okay, if we're going to justify points of inflection, and again, I know that we want to look at what is g double prime doing, but we need to start with what is g double prime of x equal to? Well, a moment ago, up at the very top, I had you write down that g prime of x is equal to f of x. So g double prime must be equal to f prime of x. So we're now looking at the slope of the graph. Okay, so now it says how many of these points. So did you answer the question? How many of these x coordinate points? Oh, there's my alarm. Okay, are the inflection points. So the first thing I would do is g double prime of x is undefined. We know at x equals 1 and x equals 2. How do we know that? They told us that, but if we go back to this, 1 and 2, those are like indentations or sharp corners, sharp points, whatever you want to talk about, okay? So the slope is undefined, but then I need to look at what happens before. So g double prime of x is greater than 0 on -2 to 1. And then g double prime is less than 0, okay, on 1 to 2. So the reason why that's an inflection point is because there's a change in sign of the second derivative, okay? But then we have to, the justification part has to talk about, so that's at x equals 1. So g double prime of 1 is undefined, okay? So that at x equals 1, there is a point of inflection, but we have to talk about why at x equals 2, there's not a point of inflection. So if I go to 2, the slope at 2 is negative beforehand, and then it's negative after. So there's no change in sign for that slope or second derivative. So at x equals 2, there is no point of inflection. And it can't just be that you have negative second derivatives on the interval before and after 2. You have to talk about, since g double prime of x does not change signs at x equals 2. Okay, all right, then if I go to this second one here, okay, this one was the hardest one that we have had so far, okay, and I need you to pay very close attention for this particular problem. First of all, if they have that it is a calculator allowed and they want to know what the acceleration is, you know that the acceleration is equal to v prime of t. So we're going to say that the acceleration of 4 is going to be v prime of 4. Go get that answer. I don't want to see you having to struggle to actually get the derivative. You're not getting any extra credit here. This is it, negative 0.524, peace out. And that's the same thing as negative pi over 6, but if you gave me the answer of negative 5 or pi over 6, I knew you did not use your calculator. Okay, you can use your calculator for 4 things. Graphing, okay, you can use it for your adding, subtracting, multiplying, dividing, simple math, right? You can also use it for calculating derivatives and calculating integrals. That's it. Those are the only 4 things. Okay, now when we get to this particular problem here, okay, what you needed to say for this, okay, that statement 1 is definitely true. And the reason why statement 1 is true, you told me that the reason why statement 1 is true is because velocity is decreasing. I'm pretty sure that if the statement tells you that the velocity is decreasing, that cannot be justification. So how do we know if a function is decreasing? What do we look at? Right? If we were looking as f of x increasing or decreasing back in chapter 4, you would have gone and looked at f prime. So if we want to talk about whether or not the velocity of the object is increasing or decreasing, we need to talk about the derivative of that velocity, which is acceleration. So you needed to talk about either v prime or a of t was less than 0 on that interval. Okay? Statement 2 is true. Why is statement 2 true? And you had to come up with, if you're going to talk about speed, okay, speed is increasing when both acceleration and velocity are the same sign. Okay, so in this, we know that v of t is less than 0, okay? But we also know that a of t is less than 0. So therefore, speed is increasing. Okay? Now, total distance traveled by this object. If you graphed this, that's great, okay? But what we need to do, whatever that graph looks like, okay, total distance means total area, all positive, okay? So if we want an all positive area, you could have done one of 2 things. You could have separated your integrals into two separate integrals, right? So you could have figured out where does it go positive or negative, etc. Okay? Or if I have this, right? I want to make sure that this becomes positive so that I count it as positive. And the one way I can do that is telling me that, or saying that the distance is going to be equal to the integral from 0 to 4, not just of v of t, because v of t is going to give me that signed area or the integral, which gives me the total displacement. I need the absolute value of that. Okay, so that's the same thing as writing 2 separate integrals and counting everything under there. Okay, so I could have written 2 separate integrals and done here and then the negative of this, or the other option is I need the absolute value. So when you get that, it will totally get you to your answer. Now, those of you who did the integral by hand, why? It's a calculator. So even if you just did 0 to 4 of that sine of pi over 3t dt, why are we going to go and do that by hand? Why? Why? Don't do it. Okay, I know that you're just learning how to do integrals, and that's great. But if you have a calculator and you've got bounds on here, you better be using your calculator to go calculate that. Okay? So in this case, I was hoping that you would have that absolute value so that this negative area in your integral would pop up to be positive. Okay? So if you're looking for total distance, you need to have absolute value around that velocity. Now, what is the position? Remember, position is equal to initial plus the change. Okay, we had a lot of people miss this. Okay, so if I want to know at t equals 4, so that's x of 4, okay? And at the very top, the very first statement says x of 0 equals 2. That is your initial position. So if I want to know what my position is at 4, my initial here is going to be x of 0 plus the change. Well, what's the change? The change is that integral, that overall integral from 0 to 4 of that sine of pi over 3t. But now I don't need absolute value because I want to know what the change is, the displacement. Okay? And again, don't do this by hand unless it says no calculator. You have an opportunity to use a calculator. Okay, x of 0 is 2. So 2 plus that integral. And instead of writing out, I can just put v of t dt. Okay, this overall integral was, I believe it was 1.432. So you ended up with 3.432. Okay, but this was the toughest one that we've so far. I would expect to see more of problems C and D on a test and on your weekly problems. Okay, have a great day. We'll see you soon.